So our lesson on circles in the coordinate plane, we're going to have to know a formula of how to find a circle in the coordinate plane. And I want you to write this down at the top of your notes. Whoa, try again. Just a minute. Arg. All right, so your formula is x minus h quantity squared plus y minus k quantity squared equals r squared. Now there's a lot of similarities from this equation to what you had for your absolute value equation. You see that h and that k variable showing up, and remember the h was the horizontal shift and the k was the vertical shift, and that's exactly what they are here today as well. And I notice that this formula seems to have built-in negatives right here and here, so we're going to treat those like we did the same way with the absolute value graphs. And r, as you would imagine for a circle, stands for radius. So when I look at number 1, the center of my circle is at the h and the k, and you'll notice there's nothing being subtracted or added to x and y, which must mean my center is at 0, 0. And then the length of my radius, remember this number that's off to the side of the equation is the radius squared. So if I think backwards, square rooting my radius squared, or square rooting a 16, would give me a radius of 4. So now the really exciting part is you have to draw a circle for me, and mine, I'm sure you can imagine, don't turn out great. So your center plotted at 0, 0, and then a radius is defined as the distance from the center of the circle to the edge of the circle. Now it's very easy for me to measure up, down, right, and left 4 units. It's a little more difficult to go diagonally. So you're going to only have to graph up 4 units, down 4 units, right 4 units, and left 4 units. And then, oh man, that's not good. Oh geez, okay. I get bonus points for doing this on a tablet. So you guys go. Make a really pretty circle. All right, number 2. Remember, inside the parentheses was the opposite, always for inside the absolute value bars is always the opposite, so the same thing goes here for circles. Remember, the negative is part of the formula. So for number 2, the center, the x-coordinate, or the h-coordinate I should call it, is actually a positive 3, and then the k-coordinate is actually a negative 4, because if you go back to the formula, he would have said y minus negative 4, and that's how it became the y plus 4. So always take opposites of whatever's in parentheses in math. And then the radius, the length of the radius, is going to be the square root of this back number. So the length of the radius is 2 units. So you're going to plot your circle at the point 3, negative 4. And then from that center, travel up, down, right, left in 2 units. And this should seem really familiar to you guys from Geo. I know about half of you did this kind of at the end of geometry last year, but you found it very easy and you liked it, so life was good. Probably didn't even have a test on it. It was just one of those bonus things you learned. Circles aren't getting any better. All right. Let me pull this out of the way. So our next set of problems, same thing, center is located at, in this case, the h value is a 0. The k value, always take opposites of parentheses, is a negative 1. The length of my radius is the square root of that back number, so the length of my radius is a 5. So to graph this, I would plot a point at 0, negative 1. And then for a radius of 5, go up, down, right, left 5 units. And there is no way I'm going to even bother trying to graph this circle, but I'm sure you can envision what this circle would look like. So number 4, center should be at positive 4, comma 0. And then the square root of 1 is one of those, it's the only strange number in the world where he is his own square root. So his radius is still a value of 1. So his center's at 4, 0 with a radius of up 1, right 1, down 1, left 1. And you would draw in the circle. Do the best you can to make them circular. I know if you draw like me, you're kind of at a disadvantage, and that's okay. Next set of questions should be nice and easy. They don't want you to do any graphing, just identify the center, identify the radius. So my center for number 5 should be 2, comma 1. We always are taking opposites of what's in parentheses or what's grouped with a variable. And then the length of the radius should be a 5. And then for number 6, the center should be at negative 12, negative 8 with a radius of 7. that is just too easy to stop there, so we need to take this up another level. I am now going to give you the center and radius, and I want you to write it as an equation. So go ahead and write down what you think the answers are to 7 and 8. I'm going to freeze the screen for the class. Obviously, the people on the internet can see what I'm doing, but that's okay. I want you guys working on 7 and on 8. On your paper. Yep. Are you getting that? X squared plus 9y squared equals 196. That's 14 squared. And then for number 8, x plus 6 quantity squared, y plus 8 quantity squared equals 36. So again, that's not hard enough for us. We need to bump it up another level. 2 items that I need in order to write the equation of a circle. I need to know the location of the center, and I need to know the length of the radius. Well, when I look here at number 9, I see the center is located at -9, -16. And then the other thing they tell me is that it goes through the point -8, -16. The definition of a radius is the distance from the center to the edge of a circle. So I think about how we warmed up today, and I think about how maybe I could identify the length of the radius if it's the distance from the center to the edge. Maybe something like using distance formula. So in order to find the radius, you're going to have to use distance formula, which you know I kind of cheat when I use distance formula. So the distance between the center and the point on the circle, if I look at my x's, it travels from a -9 to a -8. That's a distance of 1 unit, so 1 squared. And then -16 to -16 has not traveled anywhere, so that's a distance of 0 units. And that comes out to a distance of 1. I have just found my radius. So now I take the center point, which is that guy, and my radius of 1, and now I can plug that into the circle's formula. So, careful, because it's opposites for the formula. X plus 9 quantity squared. Y plus 16 quantity squared. And then at the end of the formula is always radius squared. Well, this one's a little boring because 1 squared is still a 1. Now, at number 10, yes, sir?
When the y values are the same, didn't you just have the
Yes, yes. Will says if the y's were the same, then you knew it was just a horizontal shift of a movement. So if you kind of mapped it out or drew it out or visualized it, you would see, yes, of course, it's just a distance of 1 from here to here. They're not always going to be that way, so you're welcome to use that if you can see it's a vertical or horizontal distance. But this next example, you notice how they're not the same, so we're going to definitely have to use distance formula here. Good question. So again, we have our center. I need to find distance this time between the center and that point. So -4 to -6 is 2 units, so 2 squared. 5 to 3 is another 2 units, and before you start whacking away at the calculator, 4 plus 4 is the square root of 8. I actually don't want you to do any simplifying here, because what we're about to do is take this radius, and we're going to square it to put it back into the formula. So I'm not even going to bother trying to simplify it, because I'm just going to undo the square root right now. So using my formula, and using the center they provided, x plus 4 quantity squared, and then y minus the 5 quantity squared. I'm supposed to take my radius and square it to put it on the back half of the problem. Well, square root of 8 squared is just 8. So we need to bump it up one more level because I feel like I'm not challenging you enough. The next set of problems. I give you the endpoints of the diameter. So try to visualize for me what a diameter is on a circle. It's from one end of the circle to the other going through the center. Well, remember, we said we need 2 things in order to write the equation. You need to know the center, and you need to know the length of the radius. And we've got nothing. Yeah, awesome suggestion. We could do midpoint. What would we find if we found midpoint? You'd find the center. And then once you knew the center, you could do distance to one of the ends, it doesn't matter which one, and you'll know the radius. I think we got a plan. So it would help if we remembered midpoint from 12 minutes ago. Midpoint, remember, was, yep, add the x's, divide by 2. And then same thing with the y's. Average of your x's, average of your y's. That's midpoint. So let's start there. The center of your circle is going to be at the midpoint. So 1 plus 17, we'll cut that in half. And then -6 plus -6 cut in half. Not very exciting. So 18 cut in half is 9. -6 plus -6 cut in half is -6. We just found our center. Now there's a couple of different ways you could find the length of the radius. You could either find the distance of the diameter and then cut that answer in half, or you could use the center you just found and find the distance from the center to one of the edges. So I need someone to make an executive decision. I'm going to tell you I'm going to go off the center, but I need to know which ordered pair you'd like to go to, and it doesn't matter. All right, I heard this one first, so we're going there. So to find the length of the radius, you just find the distance from the center to the edge. So for distance, 9 to 1 is 8 units. -6 to 6 is no units, which gives me an answer of square root of 64, which of course is 8. If you left it as square root of 64, that's fine, because what we're about to do. We're still not done though. I still need my equation. Now be careful, you have 3 ordered pairs floating around in this problem. I need to know the center, because that's the one that goes into my equation. So make sure you're using that guy. X minus 9 squared. Y, careful, plus 6 squared. And then radius squared would come back to a 64. 12 is going to be very similar. You are going to first find the center, and then you'll do distance formula off the center to one of the edges to find the length of your radius. I'm going to freeze the screen. I know the people out there in internet land can see us, but you guys can't. I'll meet you up in about 1 minute. Go. If you're not done, don't look. And that's probably as difficult as I'm going to make these questions. The next 2 types of questions we're going to see, they're not more difficult than that, they're just different. So, can I move? It says x plus 3 quantity squared, and then y minus 8 quantity squared equals 100. Okay. The next 2 problems, I think they tell you everything you need to know, because I need to know center, I need to know radius, so as long as you have eyes that work and you can count, I think you know those pieces of information. So your center, I can locate it, is right here, and that is the ordered pair 4, 4. Now be careful, boys and girls, when you tell me what the radius is, these grids are counting by half points. So from here to the edge is actually only a distance of 1. At first I thought it was 2 as well, because I didn't look at the axes. So knowing that information, I think we're good to go. X minus the h squared, y minus the k squared equals radius squared. 1 squared is 1. Then this last problem on the graphing, the center is at the point 1, 2. And if I count carefully, because remember these go by halves on these grids, the radius seems to be a 3. So back into the formula, x minus 1 squared, y minus 2 squared equals 9. Fairly straightforward. Now the next and the last two questions, they still trick me to this day. And the translations of things that are in the special format really mess with me, because I know that when I'm translated up 5 units, I know that changes my k value by 5. I just always forget if I'm supposed to add or subtract 5 because there's backwardsness in the formula that really bothers me. So instead, I like to give myself a graphical or visual representation, and then I can very easily see the answer, because, and I'm not trying to be coy here, guys, still to this day, I screwed up, so I have to graph it out. So I'm gonna give myself a very crude sketch. This original circle has a center at 12, negative 8. So I'm gonna draw in a really ugly 12, negative 8. I'm not even gonna draw the whole circle, because all I really care about is his center. That's the only thing that's gonna change. Now, if I took this and I translated him up 5 units, I need you to tell me where my new center is located. Well, going up changes the k value. So the 12 is still a 12, but what's the negative 8 going to be, Frank? Negative 3, good. So my new center is what I'm really interested in. Has my radius changed at all? No, so you don't have to do any mess with that. So I'm supposed to write the equation. It's still x minus 12 squared, but now the y is y plus 3 quantity squared. Still 48 on the r squared portion. And now that I sit back and look at it and go, oh, yeah, I guess that makes sense. It changed by 5 units, but again, I still debate over whether I'm supposed to add or subtract 5 units, so you'll never see me doing this without a picture. This next problem, the original center is at negative 14, 10. So like over here somewhere. And it was translated 4 units to the right, and then 5 units down. So when I move 4 units to the right, that's coming back towards the origin, 4 units, I think I'm at a negative 10. And then if I'm up at 10 and I use 5 units to go down, now I'm up at a 5. So my new center is at negative 10, 5, and my radius has not changed at all. So I just changed the formula to say x plus 10 quantity squared. And then, whoops, y minus 5 quantity squared. And it still equals 4, because the radius is still going to be a 2. That is circles in the coordinate plane.